Hello and welcome to both 8-9 and 8-11. Tonight we are doing both because they're both ridiculously easy. We're going to start with congruent figures. A congruent figure is defined as all sides and all angles are congruent. Duh. Now with triangles we've got a groovy little side rule. If all the sides are congruent, then you know that all of the angles are congruent too, which means if all the sides of the triangle are congruent, then the whole triangle is congruent. So for example, here I have triangle 4, 3, and 5, and this one, if you ignore the oops, you have 4, 3, and 5, and if you actually try this with like popsicle sticks or something, you cannot get a different triangle with all the same sides. They have to be congruent angles as well. So if all of the sides are congruent, that means the triangles are congruent. It doesn't work with other shapes. It only works with triangles. With other shapes, you can have a side of 3 and a side of 7, and a side of 3 and a side of 7, but the angles are different. So these are not congruent shapes, because both the sides and the angles have to be equal for it to be congruent. Okay? So, ta-da, that was 8-9. So, looking at it, your turn. Are they congruent? Here's 2. Here's 2. You get to tell me if they're congruent. And if I tell you that they are congruent, I want you to find the missing measure for these congruent figures, which means this and this are congruent. This and this are congruent if you ignore the little thingy there. And I need you to be able to tell me the missing measures. So hit pause, figure those out, come back. So, looking at these two. I have a 4, a 3, and a 6 here. A 4, a 3, and a 5 here. Are they congruent? No, because the sides are different. The sides and the angles have to both be the same. Here, I've got this and this are both 7. These are the same, and these are the same as those. This angle is the same as this angle. So everything about these two angles or triangles are the same. So those two are congruent. That's a yes. Number 3. This side is 4, this side is 4. This side is 6, which means this side is 6, so Z is 6. This side is X, this side is 8, which means X equals 8. This is a 90-degree angle, which means Y is 90 degrees. This is a 60-degree angle, which means W is 60 degrees. It really is this easy. Here I have 2 trapezoids, one that I flipped over, but they're still congruent. So the 50 matches up with the 50, and the X matches up with the 120, and the 130s match up, and the 60 and the Y match up. This side is 8, this side is Z. 8 and Z match. 7 and W match. V and 12 match. Okay? Next, we're doing symmetry. 8-11 is symmetry. And it's almost just like being in kindergarten. In fact, look, I drew you a butterfly. A line of symmetry is the line down the center where the two halves of the shape are reflections of each other. So you can see how this line works, but I can't draw a line this line because that's not a reflection up and down. Just like this one. I can draw a line across the center and one half folds over the other half, and that works just fine. But I can't draw a line here. Even though the shapes work out, the colors don't. And if it's in color, you got to take that into consideration. Then we have rotational symmetry. My 7th graders are going to recognize the fact that we just did this in biology too. Rotational symmetry means if you rotate it around a central point and it repeats itself, like for example a wagon wheel or a pizza or something like that, you have a center of rotation right in the middle, and if you can take it and turn it and it still fits, then it's got rotational symmetry. Okay? And this one, you could rotate it 1, 2, 3, 4, 5, 6, 7 times before you came all the way back to the end. So this has 7 rotational symmetry lines. All right? And ta-da, that's it too. You can see why I combined these two sections. So, your job is going to be to find all of the lines of symmetry in these 4, assuming I can draw straight, you know. And for the ones on the bottom, how many times can you rotate these? So these are supposed to have rotational symmetry. Tell me how many times you can rotate them without going all the way around. Okay? And as always, stars near the easy stuff, which should be everything. Triangles near the hard stuff, and highlight all of your vocabulary. Okay? And I will see you tomorrow. Take care.